Dear students, welcome to the third module of the course Basic Principles of Energy Management and Energy Audit. Myself Dr. Prashant Kumar Jena, Assistant Professor in the Department of Electrical Engineering. We all know the energy is a vital source that powers our daily lives and plays a significant role in the development and progress of the society. However, with the growing concern of climate change and the depletion of natural energy resources, it is crucial to adopt sustainable practices and ensure efficient utilization of energy resources. So, in this module, we will be exploring the various aspects of energy monitoring and planning, including the importance of monitoring the energy usage, strategies for reducing the energy consumption, and the role of energy planning in achieving sustainability. Through these classes, we will try to equip you with the necessary knowledge and skills to effectively monitor and plan for energy and contribute to create a more sustainable future. Till now, we have discussed about renewable energy resources, its consumption and its usage in our day to day life. Also, we have seen various forms of energy, their effective conversions, energy audit and management techniques. In today's lecture, I will discuss regarding the introduction that will cover what is energy monitoring and targeting, setting up energy monitoring and targeting, and the key elements of monitoring and targeting system. Before starting, let us revise about basics of energy monitoring as a prerequisite for the upcoming classes. Our world is already fraught with rising energy demands. As per the data available, the total energy consumption of the world is expected to increase by 48% before 2040 as per the report published by US Energy Information Administration. But favorably, employing the energy management system in a building that aims to make use of the energy resources effectively may save up to 29% of the energy consumption costs. So, efficient energy usage is the solution for this world's ever rising energy hunger. Now, the term energy management, it might be bringing you an image of just switching off some unused lights and appliances, but here is the fact: energy management covers more than just switching on and off lights and fans. The process also has a role to play in many areas like logistics, industrial production, machine maintenance, the energy procurement process itself, and even your personal life. Energy management is the proactive and systematic monitoring, control and optimization of an organization's energy consumption to conserve use and decrease energy costs. Energy management includes minor actions such as monitoring monthly energy bills and upgrading to energy saving light bulbs. It can mean more extensive improvements like adding insulation, installing a reflective roof covering, or improving high voltage AC, heating and cooling equipment to optimize energy performance. Energy management also includes more elaborate activities such as creating financial projections for commissioning renewable energy services and making other improvements for clean energy consumption and reduced energy costs in coming years. More sophisticated energy management programs take advantage of technology. For instance, utility tracking software predicts future energy usage and plans energy budgets, which helps a company's strategic decision makers ensure its energy management strategy correlates with its objectives and financial planning. Enterprise management software uses Internet of Things, advanced connectivity and big data, that allowing a corporation to take advantage of energy data analytics for better facility management and helps with energy consumption and energy management challenges. There are few steps for the process of energy management. Those are collecting and analyzing continuous data, identify optimizations in equipment schedules, set points and flow rates to improve energy efficiency, calculate return on investment. Units of energy saved can be metered and calculated just like units of energy delivered. Execute energy optimization solutions and repeat step 2 to continue your optimizing energy efficiency. Next, we will go to the energy monitoring and targeting. Monitoring and targeting term are used to describe a range of management techniques employed to improve the understanding of how energy is consumed and business costs are involved. This is a department of management information system for handling various information related to energy supply and usage for gaining energy efficiency. Basically, it contains two terms, that is monitoring and targeting. Monitoring is one of the management techniques where essential facilities such as production of steam, consumption of fuel, energy used in refrigeration, compressor, etc. are monitored in a plant, while targeting is the identification of levels of energy consumption which is desirable as a management objectives to work hard. Each of the energy cost center is being looked through and observed for comparison with the amount of production and other essential parameters. Both monitoring and targeting are widely used and found to be very effective. By applying these techniques, energy cost can be reduced annually in the range of 5 to 20% in various industries and plants. There are several other benefits that add to the execution of these procedures. Benefits of the monitoring and targeting. The various benefits of the monitoring and targeting in an organization includes energy cost savings, that is saving of energy cost up to 5 to 15% with gradual reductions in greenhouse gas emission and other pollutants. As we know that other than some clean renewable energy resources, that is solar and wind, most of the thermal power plants using coal, oil, gas produce greenhouse gas, which adds to the rising threat of global warming. A large chunk of the greenhouse gases that blanket the earth and trap the sun's heat are generated through energy production by burning of fossil fuels to generate electricity and heat. Fossil fuels such as coal, oil and gas are by far the largest contributor global climate change, accounting for over 75% of global greenhouse gas emissions and nearly 90% of all carbon dioxide emissions. The science is clear: to avoid the worst impact of climate change, emissions need to be reduced by almost half by 2030 and reach net zero by 2050. To accomplish this, one of the direct solution is to switch to renewable solutions. However, it is not a solution to switch to renewable solutions overnight due to its financial and technical reasons. Here are some reasons why such a rapid transition is not feasible. First is infrastructure and investment. Transitioning to renewable energy requires building new infrastructure such as solar panels, wind turbines and energy storage facilities. This requires significant investment of time and resources. Constructing these facilities, obtaining necessary permits and establishing a reliable grid that takes time. Second, intermittency and storage. Renewable sources like solar and wind are intermittent, meaning they depend on weather situations. Developing efficient energy storage solutions like advanced batteries to store excess energy for when the sun is not shining or the wind is not blowing is still an ongoing challenge. Without reliable storage, sudden shifts to renewables could lead to energy supply instability. Next, we can see grid upgrades. Integrating large scale renewable energy into existing power grids may require significant grid upgrades. The current grid system were designed for centralized fossil fuel based power generation. Incorporating distributed and fluctuating resources of renewable energy requires grid modernization to handle the two-way flow of electricity due to the renewable energy resources. Next one is technological development. While renewable technologies have advanced significantly, there is ongoing research to improve their efficiency, cost effectiveness and environmental impact. Abruptly switching could mean using less mature technologies that might not be efficient or reliable. Next, we will see economic constraints. Many economies are closely tied to fossil fuel industries. A rapid transition could lead to job losses in these sectors and economic disruptions. Governments and industries need time to plan for a just transition that includes retaining and providing alternative employment opportunities. Next, energy demand. Meeting current energy demands solely with renewables might require an overcapacity of renewable infrastructure due to intermittent supply. Balancing supply and demand is crucial to ensure a stable energy supply. Regulatory and policy frameworks. Developing and implementing new regulations, policies and incentives to support renewable energy adoption takes time. Governments need to create a conducive environment for renewables to thrive. Social acceptance. Changes on such a scale can face resistance from communities due to concerns over aesthetics, noise, land use and other local factors. Public acceptance and involvement are important for a successful transition. Supply chain constraints. Renewable technologies rely on specific materials and minerals. Rapidly scaling up production can lead to supply chain bottlenecks and environmental issues related to mining and processing these materials. Next, global dependencies. Some regions might lack the natural resources needed for certain renewable technologies. This can lead to dependencies on specific countries for critical components. So, considering the limitations at this moment, with the available energy resources, this monitoring and targeting can be a potential solution to reduce the greenhouse gas emissions and thus the rise in temperature due to global warming. Coordination of energy management policy. Implementation of energy management policy by setting target for initiation of maximum usefulness and savings opportunities for a long time. In other words, we can say the targeting initiatives can be executed towards achieving maximum profit and sustaining savings over them. This can be done by identifying the areas using excessive energy and develop some policy to improve the budget and cost savings initiatives in the organization. improved product and service costing, improvement of the servicing and cost of products by defining the energy product content and service. In a business, every time a product is delivered to a customer, there is a cost for that product. A business will succeed if the total of its revenue exceeds the total of its costs. The dilemma and challenge lie in the definition of in the end and how to measure and record the total revenues and costs at any particular point in time, so that the judgment regarding success is clear. By increasing the level of control on production process, the quality of product can be enhanced. Assisting with the acquisition of financing for energy efficiency projects. Through the accurate determination of baseline energy use levels for energy efficient project proposals and verification of services. The metering and targeting program are designed to suit the needs of the particular organization. Improved budgeting. Energy costs are a significant portion of an organization's operational expenses. By implementing energy monitoring and targeting, businesses can accurately track their energy consumption patterns over time. This data helps in forecasting energy expenses more accurately, enabling better budget allocation and financial planning. With a clearer understanding of energy consumption trends, organizations can adjust their budgets to account for fluctuations in energy costs, ultimately leading to improved financial stability. Next, better preventive maintenance. Energy monitoring systems often involve real time data collection and analysis. As a result, anomalies in energy consumption or equipment performance can be detected early on. This information can be used to identify potential equipment malfunctions or deterioration, allowing for timely preventive maintenance. By addressing issues before they escalate, organizations can minimize downtime, extend equipment lifespans and reduce the likelihood of costly emergency repairs. Improved product quality. Energy consumption can impact production process, particularly in industries that rely heavily on energy intensive equipment. Fluctuations in energy supply or equipment performance can lead to variations in production output and product quality. With energy monitoring and targeting, organizations can ensure consistent energy supply to critical processes, reducing the risk of production disruptions and maintaining a higher level of product quality and consistency. Next, it is waste avoidance. Energy monitoring and targeting provide insights into inefficient energy usage and wastage. By identifying areas of excessive energy consumption or unnecessary energy losses, organizations can take corrective actions to eliminate wasteful practices. This might involve optimizing equipment settings, eliminating energy leaks or improving operational procedures. Such measures not only result in energy savings, but also contribute to reducing overall resource waste. Next, we will go to setting up monitoring and targeting. Based on the number of sites covered and levels of metering, the following classifications are adopted to implement the metering and targeting program. Those are single site with central utility metering. Next is single site with sub metering, multiple site with central utility metering and multiple site with sub metering. So, first we will see single site with central utility metering. In this scenario, a single facility such as a building or a manufacturing plant is equipped with a central utility meter. This meter measures the overall energy consumption for the entire site. Energy data from this central meter is collected and monitored to track the total energy usage of the facility. Energy targeting involves setting specific energy consumption goals for the entire site based on the historical data, industrial standards and organizational objectives. Any deviations from the target consumption levels can be identified and addressed through energy saving initiatives. Single site with sub-metering. In this case, a single facility is divided into different areas or systems, and each of these areas is equipped with individual submeters. These submeters measure energy consumption for specific sections such as lighting, HVAC, production machinery, etc. The collected data from submeters provides a more detailed view of energy usage within the facility. Energy targeting involves setting consumption targets for each area based on its function and energy requirements. Submetering allows for more precise identification of energy intensive areas, enabling focused efforts to optimize energy usage. Next one, multi-site with central utility metering. In this scenario, an organization operates multiple sites or facilities, each with its central utility meter. The energy data from all these sites is aggregated and monitored centrally. Energy targeting involves setting energy consumption goals for each individual site and tracking their performance collectively. This approach helps identify high performing sites as well as those that might need additional attention to meet energy efficiency targets. Next, we will see multiple sites with submetering. In this setup, an organization manages multiple sites and each site is equipped with submeters to measure energy consumption for different areas or systems within that site. The data from these submeters is collected and analyzed separately for each site. Energy targeting involves setting consumption targets for various systems within each site, allowing for a granular approach to energy optimization. Additionally, comparing energy usage and performance across multiple sites can highlight best practices and areas for improvement. Next, we will see ways to increase performance of energy. First, identifying where energy saving is possible using energy audit or any other survey. Walk through inspection of various plant or industries, utilities and the process undergoing in a plant physically. It can be done by energy audit. So, in energy audit, conduct a thorough energy audit of your facilities or operations. This involves assessing energy consumption, identifying inefficiencies and pinpointing areas with the most potential for improvement. Next, data collection. Gather data on energy consumption, production processes and usage patterns. This data will serve as the foundation for identifying opportunities and setting benchmarks. Benchmarking. Compare your energy consumption and performance to industry standards and similar facilities. This helps you understand how you measure up and where improvements can be made. Next, creating awareness and motivating employees for involvement in the management activities related to energy consumption or transformation. It is achieved through setting energy performance goals. In this, set clear and achievable energy performance goals. This should align with your organization's overall objectives and be quantifiable, such as reducing energy consumption by a certain percentage within a specific time frame. Energy management team. Form a dedicatedly energy management team or designate responsible individuals. This team will oversee energy initiatives, drive implementation and ensure continuous improvement. Energy plan. Develop a comprehensive energy management plan that outlines strategies, tactics and timelines for achieving your energy goals. This plan should consider technology upgrades, behavioral changes and other initiatives. Practicing techniques related to organizational improvements, such as assigning responsibilities related to energy usage and conducting training. The various steps involves employee training. Educate your employees about energy saving practices and the importance of their contributions. Promote energy conscious behaviors, such as turning off lights and equipment when not in use. Operational changes. Implement operational changes that reduce energy waste. For instance, optimize scheduling to avoid energy intensive tasks during peak demand periods. Behavioral changes. Encourage occupants to take ownership of the energy conservation, such as adjusting thermostats for comfort and efficiency and reporting any energy related issues. Improving the current facilities where the process taking place and observation of technological efficiency. It is done by continuous monitoring. In continuous monitoring, the continuous monitoring of energy consumption and performance using data collection tools and software. Regularly analyze data to identify deviations from the targets and areas that needs improvement. Performance analysis. Analyze performance data to identify the trends, patterns and areas of inefficiency. This analysis can reveal opportunities for process optimization and behavior changes. Feedback loop. Establish a feedback loop that gathers insights from employees, stakeholders and energy management teams. Use this feedback to refine the strategies and tactics. Implementing efforts for operation and maintenance for more efficient energy usage. This needs technological upgrades. So, implement energy efficient technologies such as LED lighting, energy efficient HVAC systems and smart building controls. These upgrades may require initial investment, but can result in long term energy savings. Renewable energy integration. If feasible, integrate renewable energy resources like solar panels or wind turbines into your energy mix to generate clean energy on site. Energy management system. Utilize energy management software and systems to track energy consumption, set alerts for anomalies and provide insights for decision making. Policy and procedure updates. Update organizational policies and procedures to incorporate energy efficient practices. This ensures that energy efficiency becomes an integral part of your operations. Regular reporting. Communicate progress and results to stakeholders through regular energy performance reports. Highlight achievements, identify challenges and provide recommendations for further improvement. Next, we will go for the key elements of monitoring and targeting system. The key elements of the monitoring and targeting system are: first we will see recording. In this, first point is that data collection. gather data on energy consumption, production and related variables. This can include electricity, gas, water usage, production output, occupancy rates, weather conditions and more. Metering: install appropriate meters and sensors to measure energy usage accurately. These meters can be installed at different points within the facility to capture data from various resources. Next, we will go for analyzing. In analyzing, first is that data analysis. Process the collected data using analytical tools to identify trends, patterns and anomalies. Data analysis helps uncover areas of high energy consumption and potential inefficiencies. Energy performance indicators: you have to use energy performance indicators. In this, we have to calculate key performance metrics such as energy consumption per unit of production or energy intensity. This provides a quantitative measure of energy performance. Next, comparing. In comparing, we discuss about the benchmarking. Compare your energy consumption and performance against industry standards, historical data and similar facilities. Benchmarking helps you understand where your performance stands and where improvements are needed. Setting targets, energy performance goals. Based on the analysis and benchmarking, set specific energy performance goals. These goals should be realistic, achievable and aligned with your organization's overall objectives. Baseline establishment: determine a baseline energy consumption level using historical data. This serves as a reference point against which you can measure progress towards your targets. Monitoring: real time data monitoring. So, in this case, continuous monitoring of energy consumption and related variables in real time or at regular intervals is required. This allows you to identify deviations from expected patterns and take corrective actions promptly. Alerts and notification: configure the system to send alerts or notifications where energy consumption exceeds predefined thresholds or when anomalies are detected. Next, reporting. It is done through regular reports. By this, generate regular reports summarizing energy consumption, performance against targets, progress towards goals and any energy saving initiatives undertaken. Performance insights: use reports to communicate insights about energy consumption trends, identify areas of success and highlight challenges that need attention. Next, controlling. It is done by implementing management measures to correct any variations which may have occurred. It is achieved by checking the accuracy of energy invoice, allocating energy costs to specific departments or energy accounting centers, determining energy performance or efficiency, recording energy use so that projects intended to improve energy efficiency can be checked, highlighting performance problems in equipment monitoring systems. Last, in the summary, we will see that energy monitoring targeting is an essential tool for organizations seeking to manage and optimize their energy use, reduce costs and improve their environmental performance. It helps organizations to better understand how they are using energy, identify areas where energy is being wasted or consumed unnecessarily and to take action to reduce greenhouse gas energy consumption and associated costs. Monitoring and targeting can provide a range of benefits to the organizations including reduced energy costs, improved energy efficiency, enhanced environmental performance and increased awareness of energy use among employees and stakeholders. It can also help organizations to comply with energy regulations and demonstrate their commitment to the sustainability. Thank you.